Hello guys, so today's topic is pure tone audiometry. Pure tone audiometry is a topic in ENT and a lot of questions are asked from this topic. So let's see about this topic. So I am going to discuss only the most important questions or the most important parts which are asked in questions and not going into details of this topic. First of all, how to denote the air conduction and bone conduction of left and right ear respectively. For denoting the air conduction in the right ear, the sign is 0. For denoting the bone conduction in the right ear, the sign is like this. And for denoting the air conduction in left ear, it is cross. And for bone conduction, it is like this. So how to remember it? The easy way to remember is this is R. Okay. And inside that R, there is a circle. So you can remember it like this. How to remember left? This is X. And inside an X, there is an L. So this is the sign for the left side. Okay. So that's it. Now coming to the pure tone audiometry part, the graph part, which is very important. First of all, the 25 plus 25 decibel is the threshold for normal people. If the graph you are making is below the plus 25 threshold, means it is an abnormal. If the graph is made above the plus 25 threshold, means it is normal, means that the person can hear a sound in a non-noisy environment even when the decibel is less than 25 decibels. So that is normal. And if the sound requires plus 40 decibels, only then the person can hear, then it is an abnormal response. So how to solve these questions? If the threshold of hearing is more than 25 decibels, if the threshold of hearing is more than 25 decibels, means that the graph I will make is below 25 decibels, then it is an abnormal graph, means that the patient has some problem. And if the threshold of hearing is less than plus 25 decibel, means that the graph is below, oh sorry, above the plus 25, because here it is minus 10 0 and here it is plus 110, and this is the frequency. Okay, so if it is less than plus 25 decibels, means the graph is above, means it is a normal graph, means that the patient is normal. Okay, now step 2. The step 2 is see air conduction and bone conduction gap, AB gap. Okay, if the AB gap is more than 15 decibels, then it is a conductive hearing loss. And if the AB gap is less than 15 decibels, it is a sensory neural hearing loss. Okay, so this is how questions are solved. Now let's solve few questions, only then you will understand how to solve these questions. First of all, this particular sign and this particular sign is given over here. This particular sign stands for right side bone conduction. Okay, and this particular 0 sign stands for right side air conduction. Okay, now as you can see over here, this particular thing is a graph for right side bone conduction, and this is graph for right side air conduction. As you can see over here, that this particular graph, this air conduction graph, is abnormal, means there is some problem. Okay, and now thus we go to step 2. We see AB gap, air conduction and bone, AB gap, air conduction bone conduction gap, and we see that the gap is of course more than 15 decibels, although the markings are not given over here, but still you can feel that it is more than 15 decibels, means that this particular graph is of right sided conductive hearing loss. So this is your answer. Okay, now coming to the second question. We know that this particular graph, this particular sign and this sign stands for left sided bone conduction, and this stands for left sided air conduction. Okay, and both the graphs are below the plus 25 decibel threshold, means it is an abnormal case. And we see that the AB gap is less than 15 decibels, they are almost together, which means this is a case of left sided sensory neural hearing loss. Now coming to the third part, we can see this is a special graph. Okay, this is a special graph. You can see at 2000 hertz there is a dip. This is seen in otosclerosis, and this is known as Carhart's notch. Okay, you just have to remember it, questions are asked. This is also a special case. At 4000 there is a dip. This is called acoustic dip, and it is seen in sensory neural hearing loss. And the last graph, you can see there is an upsloping graph. The graph is going upsloping. Where is it seen? It is seen in Meniere's disease. Okay. Now coming to the last thing, let's solve a question which is a previous year question. I have taken it from Marrow. How to solve this particular question? Let's see. If you solve this question, you are fully prepared for this topic. A woman presented with an impaired hearing, her tympanogram findings are given below. Pick the right combination of tuning fork test result that would be shown in this patient. So first of all, we all know that if we see this particular graph, this stands for right-sided air conduction, okay, and X, this in over here we can see X, this stands for left-sided air conduction, okay. We can also see that this graph also has a sign like this and it has a sign like this. These signs are another signs for bone conduction of right side and bone conduction of left side, so you don't have to worry about it, okay. Now this particular graph, this red graph, is above the plus 25 decibel threshold, so it is a normal graph. And this particular blue graph is below the plus 25 threshold, so it is an abnormal graph. Now what do we see after that? We see AB gap. We see that in that blue graph, you only see the blue graph because it is abnormal. The AB gas is of course less than 15 decibel, so it must be a case of SNHL. And the blue graph is of left side ear. How can we know that is a how come we know that it is a left side ear? Because the markings are X. So if the markings are X, means it was given of left side air conduction, so left sided SNHL. So if you get a left sided SNHL case, then the Rini's test on the left ear will be positive and the Weber test will lateralize to, of course, the good ear means right ear. That's it. So this is your answer, option C. So this is how questions are asked. This is a very important topic. Thank you.